Imagine an entire planet tipped over on its side, where one pole spends 21 straight years in total darkness, while the other bakes in 21 straight years of continuous sunlight. That's not an exaggeration for effect. That's just how Uranus actually works, every single orbit for billions of years. Today, we're descending into Uranus and walking through exactly what would happen along the way. By the end, we'll get to the coldest recorded temperature of any planet's atmosphere in the entire solar system, and it's not the planet you'd expect to hold that record. Stick around for that one. The very first thing that makes Uranus unlike any other planet in our solar system has nothing to do with its surface or atmosphere. It's the way it spins. Every other major planet rotates roughly upright, more or less perpendicular to its orbit. Uranus is tilted about 98 degrees, meaning it essentially rotates on its side, rolling around the sun like a ball instead of spinning like a top. Nobody knows for certain why, but the leading theory is that billions of years ago, Uranus was struck by another massive object, possibly an Earth-sized planet, early in the solar system's history, knocking it completely off its original axis. This single fact changes almost everything about what a day or a season even means there. Because of that extreme tilt, Uranus experiences the strangest seasons of any planet. As it makes its 84-year journey around the Sun, each pole spends roughly 21 years in continuous daylight, followed by 21 years of continuous darkness, with the equator getting more typical day-night cycles only during the brief transition seasons in between. If you were standing at one of Uranus's poles, you could be born, grow into an adult, and reach middle age, all without ever seeing the sun set, or without ever seeing it rise at all, depending entirely on which pole you happen to be standing on. And once the sun is gone for those 21 years, the temperature drops to levels that compete with the coldest places anywhere in the solar system. Uranus holds a surprising record. It has the coldest atmospheric temperatures ever directly measured on any planet in our solar system, dropping to around -371 degrees Fahrenheit in its upper atmosphere, even colder than Neptune, despite Neptune being significantly farther from the Sun. The leading explanation is that Uranus's interior generates very little internal heat compared to the other gas and ice giants, for reasons scientists still don't fully understand. Most planets gradually radiate leftover heat from their formation, but Uranus seems to have lost most of that heat somewhere along the way, possibly connected to whatever massive collision knocked it onto its side in the first place. So unlike Jupiter or Saturn, where the danger ramping up as you descend is heat and pressure together, Uranus starts you off in some of the most extreme cold ever recorded, and then adds pressure on top of it. As you began descending into Uranus's atmosphere, you'd notice something unsettling almost immediately. There's very little to see. Uranus's atmosphere appears mostly smooth and featureless compared to Jupiter's swirling bands or Saturn's hexagonal storm, a pale blue-green haze caused by methane gas absorbing red light and reflecting blue and green wavelengths back into space. This calm appearance is deceiving, though, because Uranus still experiences powerful winds, reaching up to about 560 miles per hour in some regions, among the fastest in the solar system, even without the dramatic visible storm systems Jupiter and Saturn display. You'd be falling through howling invisible winds inside what looks, from a distance, like an almost perfectly smooth, calm sphere. And the deeper you fell past that deceptive calm, Uranus had one more genuinely bizarre surprise waiting. Just like its larger cousins Jupiter and Saturn, scientists believe Uranus may also experience diamond rain deep within its atmosphere. Laboratory experiments recreating the extreme pressure and temperature conditions found deep inside Uranus have shown that carbon-containing compounds can be compressed into solid diamond structures under those conditions. Because Uranus and Neptune are classified differently from Jupiter and Saturn as ice giants, containing more water, ammonia, and methane ices mixed with rock. Layered around a smaller hydrogen-helium atmosphere, researchers believe these compounds could be triggering similar diamond-forming reactions deep in their interiors, just through a slightly different chemical pathway than the gas giants. So somewhere beneath that pale, calm blue-green haze, in crushing pressure and near absolute zero cold, there may be diamonds quietly forming and sinking, completely inaccessible, just like on Saturn and Jupiter. Continue falling deeper, and you'd eventually reach Uranus's mantle, a thick layer scientists describe as an extremely dense, hot, slushy mixture of water, ammonia, and methane ices, under pressure so extreme that it behaves almost like a superheated, electrically conductive ocean, rather than the solid ice you'd recognize on Earth. An unprotected human wouldn't survive anywhere close to this depth. The combination of crushing pressure and increasing internal heat, the deeper you go, would be lethal long before reaching this slushy mantle layer, despite the freezing cold you started in near the cloud tops. Uranus's interior is believed to hold a relatively small, dense, rocky core at its very center, buried under thousands of miles of this strange, icy, electrically active material above it. By the time you'd reach any meaningful depth, the planet would have killed you through cold, then crushed you through pressure, all within the same descent. So here's Uranus in full, tipped completely onto its side, with seasons that last 21 years of unbroken daylight or darkness, the coldest measured atmosphere of any planet in our solar system. Deceptively calm skies hiding winds over 500 miles per hour, possible diamond rain falling somewhere deep inside it, and a slushy, crushing interior that no human body could ever survive reaching. It's quiet and pale from a distance, almost gentle-looking, and it might be the most genuinely alien planet on this entire list. Up next, we're heading to the very edge of the solar system, to a planet with the fastest winds ever recorded anywhere on any planet, period. Stick around for that one.